Honey is a remarkable substance. It's a natural sweetener that has been enjoyed for centuries, but here's the truly amazing part. Honey never goes bad. Archaeologists have even found pots of edible honey in ancient Egyptian tombs. Imagine that honey that's thousands of years old and still good to eat. How is this possible? What is it about honey that makes it last practically forever? The answer lies in a fascinating combination of chemistry, biology, and the hard work of honeybees. Let's dive into the science behind honey's incredible shelf life. Honey's longevity is due to its unique composition. Honey is very low in water content. This is important because bacteria and microorganisms, which cause spoilage in most foods, need water to survive. The low water content dehydrates microorganisms, preventing them from thriving and spoiling the honey. Beyond the low water content, honey possesses a special ingredient, an enzyme called glucose oxidase. Bees add this enzyme to the nectar they collect. Glucose oxidase breaks down sugars in the honey, producing a substance called gluconic acid. Gluconic acid is a natural preservative. It creates an acidic environment within the honey, which further inhibits the growth of bacteria and other unwelcome guests. Honey's remarkable properties have been recognized for millennia. Ancient civilizations across the globe treasured honey. They used it not only as a sweetener, but also for its medicinal properties. In ancient Egypt, honey was used to treat wounds and burns. The Egyptians also used honey in their religious ceremonies and as an offering to their gods. The ancient Greeks also valued honey highly. They believed it had healing powers and used it to treat various ailments. And honey was also an important ingredient in their food and drinks. The Greeks even had a god of honey named Aristaeus, who was said to have taught humans the art of beekeeping. The creation of honey is a fascinating process that starts with bees and flowers. Bees collect nectar, a sugary liquid from flowers. They store this nectar in a special sac called a honey stomach. Inside the honey stomach, enzymes begin breaking down the complex sugars in the nectar into simpler sugars, like glucose and fructose. Back at the hive, worker bees receive the nectar from the foraging bees. They then deposit the nectar into the honeycomb cells. The bees fan their wings over the honeycomb, evaporating water from the nectar. This process thickens the nectar, making it more concentrated. As the water evaporates and the sugars concentrate, the nectar transforms into honey. The bees then seal the honeycomb cells with beeswax, preserving the honey inside.